A dream written down with a date becomes a goal. A goal broken down into steps becomes a plan. A plan broken by action makes your dream come true. Welcome to all gathered here this evening. It gives me immense pleasure in welcoming every one of you to this online summer course on Evolution and Advances in Electronics and Communication Technology, Part 2. I now extend a warm welcome to our resource person for this evening, Dr. Benjamin Joseph, on behalf of our respected college chairman, Sri D. Duraisamy, Vice Chairman, Sri D. Parandaman, Secretary, Sri D. Dasarathan, Joint Secretary, Sri S. Gopinath, Correspondent, Sri S. Amarnath, Director, Sri D. Sabarinath, our beloved Principal, Dr. S. Ramachandran, Head of all UG and PG departments, professors, faculty members, and students of our institution. Before we begin this event, let me share a brief introduction of our institution. Dharma Naidu Educational and Charitable Trust established ECE Engineering College in the year 1998-1999. We are a NAC A grade and ISO 9001-2015 certified institutions located at Tiruvekadu. All our departments are NBA accredited. We are working autonomous from 2019 for a span of 10 years. We have 24 years of excellence with 9 UG programs, which include BE ECE, EEE, CSE, Civil, Mechanical, and BTech IT, Artificial Intelligence and Data Science, Computer Science and Business System, along with 6 UG programs which are ME CAD CAM, CSE, Communication System and Embedded Systems Technology, MBA and MCE. We also support various doctorate programs in CSE, ECE, EEE, Mathematics and Mechanical Engineering. SA Engineering College stands out in the crowd for its Anna University recognized research centers with 27 funded projects where students get chance to work on this project. We provide highly comprehensive placement of about 90% each and every year. We have achieved 90% of placements even during this pandemic in the year 2020-2021. Our top recruiters include Avasoft, Rapid Data, Emphasis, Infosys, Capgemini, CTS, TCS, Zoho, L&T. We have introduced latest courses on Artificial Intelligence and Data Science, CSE and Business Systems. We have a state-of-art infrastructure including Internet of Things Lab, Product Design and Development Lab to conduct research projects. SA Engineering College maintains high standard of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members, and creating an ambience of conducive quality education. I now request our resource person to take over.
Good evening to one and all present here. I'm thinking so I'm audible to everyone. Just say yes in your comment boxes if I am audible. And I'm Dr. Benjamin Joseph. I'm going to handle you the second series of this webinar, and I'll be taking about communication, and I'll be taking about the Internet of Things today. Before going into the depth of the communications or an IoT, just we'll have a fun today. The fun in the senses will play some connectivity game such that those who are here will be somewhat, you will be active. And I extremely welcome the professors who are present here and my dear students and my dear friends who are all here, everyone, I'm giving a warm welcome to who are present over here. Now just we'll start with the connection game. Once I'll display the slide, if you're able to identify, just identify. First we'll just start with a simple connectivity program. Okay, fine. Now, first we'll go with this. Can you able to identify the device over here? Anyone, please? Can you please identify the device over here? I think the time is enough for you to see the thing. Now I'll come into the comment box. How many of you can able to answer this? Could you able to answer what I'm saying? All right. For example, see here, I'm displaying a device, right? There are two pictures. You can connect these two pictures and you can say what device is this. And then we'll move on into today's session. Anyone over here can say the answer. Anyone who are present. Yeah, very good. In private chat, I got an answer from Kavi Priya. It's a great job. It's diode, right? One is di and another one is odd. So combinationally, we call it to be a diode. And once again, everyone, now listen over here. We'll go to the today's session. In today's session, right, it is a series 2, right? Once again, I'll start with the proverb. If you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. But whatever you do, you have to keep moving forward, my dear students and colleagues. Okay, so don't be stagnant in your life. Move on with good ambition and goal. Now let's move on into the today's agenda, that is day-to-day communication. The first one I'm going to say about the objectives of this program, then introduction of communication, evolution of communication, signal parameters, because without signal there is no transmission, basic types of communication, significant branches of communication, generation of mobile communication technique, Internet of Things, application of IoT. We are going to see two videos, basic courses in ECE, advanced courses in ECE, job opportunities for ECE engineers, then reason to consider higher studies. This is how the flow goes today with the presentation. First, objective. Right, whenever we are doing certain things, we should have a very clear, practical, ideal, a goal, and objective. Without a goal, you cannot achieve anything, my dear. So I'm defining an objective of this second day series is, whomever are not aware about what is communication, what is the literal meaning of a communication. Many times we learn about the communication, we use the word again, communication, but we don't know exactly what it is. To make aware of fundamentals of signals, right? Without a signal, you cannot communicate. Then the fundamentals of IoT, because yesterday we learned about sensors, and today we are going to learn about communication. Both these signals and your electronic component is going to frame out your IoT devices and the job opportunities about and the higher studies. Now let me move on into the first step, introduction to communication, right? And before that, let me go with a quote. Silent isn't golden, and it surely doesn't mean consent. So start practicing the art of communication. You can't be always silent in this world. You have to start communicating for whatever task you want to do with. Without communication, you cannot achieve anything. Where this word communication comes from, many people are aware where this word is come, where this English word is being originated. It comes from the Latin word called as a communicator, which is mean sharing or imparting. Now, a different perspective, if I want to see into a communication, the communication word can be splitted into three things like this. Communication. What does it mean? Come in union for exchange of information. Come in union for exchange of information. If only a single person is there or a single device is there, you cannot communicate. But when there are more than one device, suppose one device and then another device, it can communicate. And also, if there is only a single person, what he can talk? No, only he can transmit. It's not like that. There should be another person to communicate with you. So only there will be a communication. All right, so you have to come in union for exchange of what? Information, and not the data. There is a lot difference between the data and the information. data always contain the repeated words or the repeated meanings, but information is always new to us. And my presentation should be an information to you and not the data. Should not be a repeated one. And once again, communication, the word is originated from the Latin communicato, and you're coming in union for exchange of information. So from this definition, how I'm going to come into the elements of communication, right? Whenever you're going to communicate, one should talk and one should hear. Now, here, if you consider, now I'm talking as a resource person and you are listening over here. So I'm acting as a transmitter and you're receiving. And the medium through which I'm communicating, now I'm using my laptop and other things, and those who are being logged in and laptop might be, you might have been logged in your mobiles or something like that. Anyhow, we are doing a wireless communication and some people are doing a wired communication. So that we call it to be a channel which connects the transmitter and the receiver is called as a channel. What is exchanged between the transmitter and the receiver? Information is exchanged between the transmitter and the receiver. Information is transferred between the transmitter and the receiver. So these are the more important elements of communication. In addition to this, we can elaborate, but you will be learning when you enter into the engineering courses of an ECE. And this world, if you consider now, it's nothing without the communication. And I don't hope so, my dear students, as well as the faculties and whomever working in IT company or whatever, from whichever domain, can you live without a mobile? It's very tough. We can live, but in nowadays era, to come up with the what to say is to go in with face, we require this mobile devices and many communication devices. We cannot say that mobile alone are communication devices, where the in case of the police officers using a walkie-talkie, that is a communication devices. In your defense department, whatever they are using, the devices they are using for the communication, it is a communication device. Without all these devices, we cannot have a successful world. So a communication plays a vital role in day-to-day life. Now let's see this block diagram. You have an input signal. We'll see what is a signal in detail. The signal will be given to a transmitter and the transmission channel will be there and your receiver will be there, and there is a destination. And your input signal, we will define it, and output signal also we will define it. Now listen here. Whenever there is a channel, there will be a noise. Okay, whenever we are transmitting, many number of noises are there. Environmental noises are there, right? And machinery noises are there, or we call it to be a, that is device noise. We can have a device noise or an environmental noise. How I can infer that environmental noise? When it is raining, when you're talking in a mobile, you cannot hear it very clearly. But when you're hearing through, what to say is, when you're hearing in an ordinary environment, or when you are hearing in an airy environment, there will be a noise. And also, if the device is providing some errors, then you will get a noise. So these noises are considered to be a disturbances. So in a course of an ECE, you will be clearly learning about this channel very much, and also the transmitter and the receiver, and how to eliminate these noises. I think I'm clear. Okay, a transmitter, it will transmit an information. Receiver will receive an information. And one more important information I have to give you. And mobile, if you take any devices, it cannot be a standalone, a transmitter alone. Suppose if you take a mobile cannot be a transmitter alone. It has to act as a transponder. That means it should act as a transmitter and receiver. I hope so I'm clear to the point. Now I'm going to the next slide. I hope so you understand this. Second thing, we are going to see now a video, the evolution of communication. I hope so you're ready to watch it. I'm just playing the video. Just note down how the communication is evolved.
Hi friends, I am Joy.
And I'm Jennifer.
Welcome to the world of communication.
So, today we are going to show you the evolution of communication.
journey of communication started with the caveman. The cavemen used to gather around a fire to discuss their day-to-day activities. We can compare this to modern-day social networking sites such as Facebook. The one sudden day they decided to record their activities or knowledge. The cavemen then started to inscribing on the caves. We can compare this to modern-day blogging. The problem with this communication method was it was localized. When people started moving out of the cave, long-distance communication became very important.
Smoke signal. This was the first long-distance communication. It was used in northern America where each tribe has its own signaling system. A smoke from top of the hill signified danger. Smoke signal was also used in ancient China. The soldiers stationed at the Great Wall would alert for danger using smoke signal from tower to tower. In this way, they could transmit message as far as 750 kilometers within a few hours. The smoke signal is still used in Vatican to indicate the selection of new pope.
Pigeons. Due to their natural homing ability, pigeons were extensively used for long-distance communication. The pigeons were used by Persians, Romans, Greeks, Mongols. In 19th century, pigeons were also used to transmit stock quotations from one city to another. Cherami, a homing pigeon, was awarded the French War Cross for her services during World War I. TV series Game of Thrones has shown the use of raven instead of pigeon for long-distance communication.
Pony Express. From ancient time, kings have been using human messenger to relay messages. Pony Express was the first of its kind mail service delivering messages, mails, newspapers, and small packages by horseback using small relay stations. It is regarded as the first courier service. It was used in the mid-19th century to communicate between the East Coast and West Coast of America.
Semaphore flag. Semaphore flag was used in maritime during the late 19th century. The word semaphore is derived from Greek word sema meaning sign and pharaoh meaning bearer. It is the telegraphy system conveying information at a distance by means of visual signals with handheld flags, rods, and discs. It is still used during underway replenishment at sea and is acceptable mode of communication for emergency.
Telegraph. Telegraphy was the greatest breakthrough in the field of communication. Although the smoke signal and semaphore flags were different form of telegraphy, but the harnessing of electricity in the late 19th century gave birth to electric telegraphy. Morse code is still used globally as a mode of communication. Till a couple of decades ago, telegraphy was the most popular form of long-distance communication. The U.S. discontinued the use of telegraph in 2006. India's BSNL telegraph service ended in 2013. It was reportedly the world's last existing true electric commercial telegraph system.
Radio. The term radio in Latin means beam of light. In 1864, James Clerk Maxwell showed mathematically that electromagnetic waves could propagate through free space. The effects of electromagnetic waves were observed before and after Maxwell, but no one could detect its presence. In 1886, Heinrich Hertz established the existence of electromagnetic waves. In 1888, he demonstrated that one could produce and detect electromagnetic waves, which we today call as radio waves. In November 1894, Jagdish Chandra Bose at Town Hall of Kolkata ignited gunpowder and rang a bell kept at a distance using microwave. During the same time, an Italian scientist Guglielmo Marconi made an electric bell which went off during lightning. This was just the beginning of a whole new era of distant communication. Early 20th century radio system transmitted message using continuous waves only. Amplitude modulation was demonstrated for the transmission of voice and music, but with little success. World War I accelerated the development of radio for military communication. After the war, commercial radio broadcasting began in 1920 and was a big hit. World War II again accelerated the development of wartime purposes for aircraft and land communication.
Telephone. Until now, real-time communication was confined to diplomatic purposes before broadcasting. Still, telegram was the fastest one-to-one communication used by common people. In 1876, Alexander Graham Bell invented the telephone. At first, the benefits of a telephone exchange were not exploited. Instead, telephones were leased in pairs to a subscriber. who had to arrange for a telegraph contractor to construct a line between them, for example between a home and a shop. It was a luxury that only rich people could afford. Later telephones took advantage of the exchange principle already employed in telegraph networks. Each telephone was wired to a local telephone exchange, and the exchanges were wired together with trunks. Networks were connected in a hierarchical manner until they spanned cities, countries, continents, and oceans. This was the beginning of the Public Switch Telephone Network, or PSTN. The major progress took place after the Second World War.
So friends, here we have seen history of communication started from caveman to telephone. But this is just the beginning of a golden era in the field of communication.
In the next video we will talk about how communications
And you have seen now the video clearly how the communication originated. And now you may wonder that why these videos are important. Actually, whenever we are learning something, that history is very important. Nowadays, the students are not learning about the preface of the textbook or what about the textbook and what's the author is coming to say or the content of the textbook. When you generally read that, you will be having an interest and you will try to understand and you will be able to understand what will be given inside the textbook. You will be having some expectation or or you will be in a vague way. So I don't want you to be like that. So I give just an insight how our communication started. But for any communication which is very important, you cannot communicate without a signal. Okay, a signal can be a voice signal, it could be a image, and it could be also a video signal. If you consider it to be a voice signal, it will be a one-dimensional signal. Image, it will be a two-dimensional signal. And video, if you consider it is a three-dimensional signal. So in our mobile, mostly we are using this voice communication, GIFs or whatever might be, or emojis, everything in the form of an image of different formats. And we are using a video chatting and video establishing for taking the classes and all other things. So we are using the video. So this knowing about the basic form of a signal is very important. Now let me go into what is a signal. A signal is a physical quantity that varies with any variable. Usually they'll consider in our department as time, but here it can be of any variable. Okay. For example, if you consider a function that varies with x or a function that varies with the time. So what is a physical quantity is anything that is measurable, we call it to be a physical quantity. For example, temperature is a physical quantity. It varies with the time period. And if you consider velocity, it is a physical quantity. It could be measured. Time, yeah, it could be measured. Any physical quantity that are varying, we call it to be a signal. All right. So now signal, already I told 1D. In case of ECG, if you consider the ECG signal which we are measuring is a one-dimensional signal, and if it's an image, it is a two-dimensional signal because image is plotted like this. When you consider image is plotted like this because it will be having an x-axis, right, and it will be having a y-axis. But in video, you will be having another dimension, that is a time period, because the image running across a time period, we call it to be a video. Now, there are two different basic kinds of signal, which is very, very important when we are further going to move, before going into move, that is analog signal and a digital signal. Analog signal is always a continuous signal in time period as well as the amplitude. But digital signals is a sequence of discrete values. For that explanation, see here you are having a continuous signal, here you are having a discrete signal. Yet more, I'll go to the whiteboard such that you will be understanding the basic thing. Now listen here. Anyhow, in a signal when we are measuring, we'll be taking the x-axis to be the time period, and the y-axis is the function of a time period. If it is an analog signal, it will be continuous like this. It will be flowing like this. All right, now see here, this time period cannot be separated, it is continuous. And also your amplitude, we call this level from here to here, what you're measuring, usually the amplitude is measured in volts, will be having like that, and this time period will be given as milliseconds or seconds, you can give it. Both this time period and the voltage are not separated. For example, if it's one cycle, you would have learned in the 11th and 12th standard, and those who are aware of it, it's okay. For example, it is from 0 to pi, pi to 2 pi. That is, one positive and one negative will give an idea about one cycle. It is one cycle. Here, this time period and amplitude noted down. It is very important because when I'm going to explain about the parameters, just I'll refresh and go it off. So if I want to define the signal, I cannot define the signal at a particular time period. Suppose this having an amplitude A, then I'll be defining it as A sine the frequency omega t, where t is lying between 0 to 2 pi. I cannot define the signal at what to say is pi by 2 or pi or 3 pi or something like that. I can define only at a particular range. Then that kind of a signal is called as an analog signal. Whether analog signal exists in this world, anyone can say that analog signal is, right? Naturally, whatever I see, whatever I see, whatever I talk, everything is analog. Naturally, whatever is available is an analog. We don't have a digital signal, because the digital signal usually it is processed by the machines and not by the human beings, because I cannot say read it as 1 0 a word. I cannot understand as an ASCII code. A human brain will always understand an analog signal. In controversy to that, or in opposite to that, contradiction to that, we have a discrete signal. Usually discrete signal, this x-axis you will be calling as n, and the y-axis you will be calling as f of n or x of n, whatever might be. Here you will be using a square bracket, and this subject you will be learning as the base in the 3rd semester. And also, if you consider about this function, what happens is this n will be an integer. So 0, 1, 2, 3, 4. At that particular point, I can define this as 1, and this as 2, and this as 3, and this as 4. So at each and every time period, that is at each and every sample, you have a discrete value. Here it is 1, here it is 2, here it is 3, here it is 4. So how can I define the signal as f of 0 is equal to 1, f of 1 is equal to 2. Similarly, f of 2 is equal to 3. Like that we can define. So like that only, and this signal are called as a discrete signal, or we call it to be a digital signal. Now most of the days now we are using a digital signal, but what is the real state is only the available signal is an analog signal. We are converting that analog signal into a digital signal. All right, so this is the base of the signal. Now let's see the parameters of the signal. If you see the parameters of the signal, what are the different parameters? We'll just wait a second. The parameters of the signal, when you consider, it is very important to learn about the parameters of the signal. Then only you will be understanding the various generations of the signal. Now listen here. I am drawing a positive cycle and a negative cycle. Now let's talk about the parameter. The first parameter, which is very important, is your amplitude. The first parameter, which is very important, is amplitude. Second important parameter is your time period. Okay, if I know the time period, obviously you can calculate your frequency, because frequency is 1 divided by time period. All right, so one parameter I got is as amplitude. Amplitude is always in volts. Second one we got it as a time period, and another one we call it to be a frequency. And always the frequency and this time period will determine your speed of communication, right? And also, another important parameter of a communication is wavelength, and this you will be giving in hertz, this you will be giving in seconds, this you will be giving in volts, and this you will be giving in, actually speed will be what you will be giving by meter per second or kilometer per second, whatever might be. It is distance divided by time, and you will be having a wavelength lambda, and usually lambda will be equal to, depending upon the material, it is c divided by f, and its unit will be given in meters or centimeters, something like that. And all these parameters are important, and another parameters which is important is an angular frequency, which is equal to omega is equal to 2 pi f. And again, if you come across, you will be having a phase shift called as a beta. This beta and all you will be learning in detail when you're having your beta is just a radians only. We can make in radians per second. Yesterday itself I told you what is a radian. I have explained you. So now listen here. What are all the important parameter? Now you got it. Amplitude, time period, and next the very important, these three things are important: frequency, speed, and wavelength. This is going to differentiate your communication as whether it is a 2G or 3G, and now we are moving into 5G. This one day it's going to differ. Which one? The frequency, speed, and the wavelength. So without knowing this fundamental, we can't move into the further the depth of the communication. Many times we, in between, I'm just giving certain sayings. Many times what we do is we don't know the fundamental, we don't know what is going on, but we know the technology, but we don't know how it works, how it operates. But the engineers cannot be like that. Engineers have to know why it comes, and how it works. And if I modify certain parameter, what will happen to the output? And all this thinking should be within the engineers. Now, once again, we'll go into your slides. Now, parameters already we have seen, that is amplitude, frequency, time period, and wavelength. These are all very important things that you need to consider. We have very less number of time, so I have to take many things. We'll go, okay, go with the flow. I hope so you understood all these things. Now listen here, the basic types of communications. This is very, very important. One, we have an analog communication. Now you know very clearly what is an analog signal. It will be continuous in nature. Now the next is a digital communication, which uses a digital signal. In case of a digital signal, you know it is a discrete signal. All right. Now, so one word I have to use, that is modulation. It is very important in the communication. Again, in generation, that is so 2G, 3G, this word is very important, modulation. Many wonder what is the modulation, right? I'll give a simple example, right? If I want to, in olden days, I want to send a letter. I need to send a letter. I'll be writing something, right? I like you, right? I'm sending a letter like that. I'm writing a letter. But this letter, I cannot send it as it is because the quality of paper will be less, and I'm fear that my message will be erased or not. So what I'll be doing is I'll be covering with a wrap. I'll be covering with a wrap according to the size of the inner letter. If the inner letter is very large, then I have to use very huge size of a covering letter. You know this concept, right? And this message you're writing now, this is called as a message signal, and this is called as a carrier signal. Carrier signal. Always the message signal will be of low frequency, and the carrier signal will be of high frequency. Okay, so if I'm hiding or if I'm imposing my message signal into a carrier signal, that is called as modulation. I hope so I made some basic understanding for you, right? I need to carry my message signal to a longer distance, but it is a very low frequency. It cannot travel a longer distance. So if I want to travel a longer distance, then I have to do a modulation, that I have to impact, that is I have to cover it with a carrier signal. It's a very simple concept, right? And also many other advantages are there. When you are going into the course, you will learn it. Okay. So in modulation also, like analog communication and digital communication, the modulation has an analog modulation and digital modulation. As you have seen in the video, right? Usually the analog modulation in ancient days, it is used as amplitude modulation, frequency modulation, and then your phase modulation. Mostly you will be using AM and FM. PM, in later cases of digital modulation, you will be using it. Next, digital modulation, they have given us amplitude shift keying, frequency shift keying, and phase shift keying. But above that also, many digital modulations are there, right? Which you will be learning. In PSK itself, you will be learning about binary phase shift keying, quadrature phase shift keying. These are all very advantageous one. This only will be using in 4th generation and 5th generations of communication. But anyhow, you have to know what is a modulation, at least the basic. There are two types of modulation, analog and a digital modulation. Next, then I said that transmitter and receiver. At the transmitter, you will be doing modulation. At the receiver, you will be doing the demodulation. Once again, receiver, what you will do when you receive the letter, what you will do, you will throw away the carrier, right? The outer cover I don't require, only I require the message. That only I'll be doing in demodulation. Okay, I'll throw the carrier signal, I'll take the message signal. It's simple. Now between that, one thing is there. What is that is, right? The transmitter and receiver are connected by, I told you, transmitter, receiver, but there should be some medium of exchange of information that is called as a transmission media. What is a transmission media? There are two different types of transmission media. One is guided in the senses it is a propagating, that is wired, right? Unguided, that is wireless. Today we are mostly relied on what? A wireless communication. What is a wireless communication? I'm not going to use any physical connectivity. Here there should be a physical connectivity. So example of a guided is, in olden days we used a telephone cable, right? Twisted pair cable and a coaxial cable. These two things we used in a telephone wires, that are called example for the guided. That is a transmission line. In case of a fiber optic cable, if you consider, now we are using a fiber optic cable. Why we are using a fiber optic cable is to increase the speed, because light travels more fast. You know that it is traveling in 3 into 10 power 8, that is meter per second. So we have to increase the speed. Wherever you will be using a fiber optic cable. Now unguided means wireless. Wireless in the senses, wherever there is a wireless, you will be having an antenna. Now you may say that whether the mobile has an antenna. Yes, a very small antenna is present inside the mobile. Most of them not aware of that, you know it. Why the antenna is not visible outside is, since the frequency is very high, the carrier frequency, whatever you are using in unguided, mostly it is a microwave frequency. Microwave frequency in the senses, it will be in terms of gigahertz. So it is in gigahertz, means lambda will be reduced. If lambda, that is, you know that lambda equal to C by F, if this is high, it is inversely proportional, so lambda is less. If lambda is less, obviously the height of the antenna will be less. So one day I couldn't able to see the what to say is the antenna in the mobile or in any devices. Actually, we do have antenna in the wireless devices. So usually the communication will be taking place through the radio waves, right? Or infrared waves, or a very high microwave in the satellite communication. Yet more, we have many other wireless communication also, but all this different kind of radio communication or infrared communication or your Bluetooth, if you take it, right? And all this satellite communication all happens through an antenna. All right. So to summarize it off, the communication has an analog communication as well as a digital communication. All right. In that, with that base as a concept, your modulation and demodulation is that. Modulation in the senses, my imposing of my message signal into a carrier signal. Carrier signal will be always a high frequency signal. Message signal will be always a low frequency signal. At the receiver, I want to unpack it. When you want to unpack it, just remove the carrier signal and receive the message signal. That we call it to be a demodulation. Now, if I want to, at the transmitter, now Just to chain the block, you will be having a transmitter. From the transmitter, you will be having a modulator, right? From the modulator, there will be a channel. The channel can be a wired channel or a wireless channel depending upon the requirement. Then you will be having a demodulator where you separate the message signal. Then there should be a receiver. Then there should be a here. When you consider, there should be a receiver. So this is the flow of a communication. I hope so I am doing some justice, the basic justice for you, because I cannot take everything at a glance. I'm just giving the fundamental. Actually, these fundamental you have learned in the 12th standard, and also if you are a beginner in engineering, you would have learned. But anyhow, to be a very clear and to be in a very practical way, I'm taking these things. Next, if you consider the significant branches of communication, usually there are various branches of communication, but nowadays the very what to say is the significant branches of communication, if you take it out, it is a mobile or a wireless communication, right? Generally we call it to be a cellular mobile communication. And then we'll talk about a satellite communication. I'm saying there are a lot of communication, but these are very important because in aerospace and all these things, in space, you will be using a satellite communication. For commercial purpose, you will be using cellular mobile communication and a optical fiber communication. All right. So I hope so you understand the branches of communication. Now we'll see about everyone now talking about 2G, 3G, 4G and 5G. Now we are in the era of 5G, right? When it is introduced, the first 2G is introduced in 1993. I'm not going to talk much about this technology because you won't understand that, but I can talk about the frequency over here, okay? And TDMA, CDMA and all, you won't understand, but just have a look over it. It is and all access technique, right? How we are going to transmit the information. That techniques we call it to be an access technique. In future, if we are conducting a series, we'll talk about these things also. And also in 1993, now latestly it is introduced in the 2018. What is the difference between all these things? If you note it down, even if you're talking about the technology and access system and switching type, all these things are important, but the very important is a bandwidth. Now see here, this is only 25 megahertz, which is entirely, there is no much change between the 2G and 3G. But see here, the shift between the 3G and 4G, obviously what happens? It is 100 megahertz. And now see here, it is using an mm waves, that is a millimeter, that is more than less than a microwave, millimicrowave. It is going into 30 gigahertz. Why we call this mm waves is, if you, I already told that lambda is equal to C by F. If F is keep on increasing, this lambda will get reduced, right? This lambda will get reduced. And another term, let us see over here. It is an art. Everything is bounded by a mathematics. F is equal to 1 by T. If F increases, what happens? Time will get reduced. Time will get what? Reduced. Now let us go to the definition of the speed. Speed is equal to what? Distance divided by time. If time is getting reduced, it is inversely proportional. Speed will get increased. Simple. If you learn the logic like this, then you won't forget and you will know why we are going for this. Why we are having, when the frequency increases, why the speed is getting increased, right? And also the bandwidth. When we are talking about the bandwidth, it is a very big story. If I'm going to talk about the bandwidth, it has a very vast ideas about the bandwidth, because bandwidth matters a lot. Bandwidth in the sense is, just I'll show a pictorial representation also, then I'll go with the thing. Then it is very general talk only. Up to this only we'll have a technical talk. If you consider this bandwidth in the senses, suppose if I'm going like this, between these two frequency, the successful transmission where there is no distortion or attenuation is minimum. The successful transmission, we call it to be a bandwidth. Usually our ECE students will know very well about the bandwidth. They'll say that it is F2 minus, once they ask the bandwidth, they'll say easily the formula. but the exact meaning is that is what the thing is. It is a successful transmission with minimum number of error. We call it to be a bandwidth. So once again, we are coming to the slide. So these are the very important thing. Now listen here, what are the advantages of 5G? Your high resolution video, and also now we are entering into the medical procedures, robots, control of vehicle. Now we are entering into Internet of Things. For this 5G is very important because I'm going to connect the various devices. When I want to connect various devices, I require a high speed. Okay, and also a high resolution, and that is another a big topic in the electronics and communication. So if you enter into the EC department, you will be learning all these things in detail, and it's quite interesting and magical. Now Internet of Things, now we have learned yesterday, very important. Now only we are coming into the very important, that is current and emerging trend. Yesterday we talked about electronics, and today we talked about communication, the base of the communication extending up to 5G, extending up to 5G. Now in electronics, one of the device I told that it is sensor. The passive devices is a sensor. When sensor along with the communication, we'll get an Internet of Things. Now listen here, right? You're going to, what is an Internet of Things? It is a connected devices. It is a connected device. I'll show a video, then you will understand. And connected devices in the senses. Suppose in your hospital, if you take it, I'm taking many readings of the patient, right, using the sensor, right? Suppose here one sensor is there, here is one sensor, here in the different rooms you are having different sensors, or else you take a home also, I'm having a different sensors, and sensors will be giving out the data. Sensors will be giving out the data, and that data will be stored in the cloud, and it will be processed. And this IoT consists both of software plus hardware. Okay, so you are storing in cloud. How it is processed? So one thing you will do it is, here there are three terminals in IoT. One is IoT terminals or devices. Terminals means devices, that is sensors. That is sensors. Second one, we call it to be an edge computing. Second one, we call it to be edge computing. There only you will be using the artificial intelligence, machine learning, and artificial intelligence will be used in edge computing. And third one is a cloud storage. Third one is a cloud storage. Now see here, medically I'm getting the data, cloud, it is processed, and I'm going to say that whether the patient is in good condition or in bad condition, he is well or sick, right? We can say that sick or not sick, good or bad. Now this should be interfaced to whom? To the doctors, mobile or any devices, laptop or something like that, to the attendants, that is to the family members. So you require a user interface. A simple example, okay, I didn't give. So you're connecting the devices through a cloud, you're processing through machine learning and artificial intelligence, okay. And machine learning and artificial intelligence, if you consider, it is just a logical programming methodology, or how you train the system, right? And nothing more in that. And then you're going to do a cloud storage, because you have a cloud storage means it's like a memory device only. Since you're storing a very huge number of data, some protocols are there, that is gateway protocols are there in the cloud storage. So there we go with the cloud storage. And now we'll go into the video. With that video, then we'll go into the roles.
The Internet of Things, or IoT, is influencing our lifestyle, the way we react to the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch which is tracking your daily activities. IoT is a giant network of connected devices. These devices gather and share data about how they're used and the environment in which they are operating. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electronic appliances, do they share this huge amount of data, and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data, and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analysis is performed on the data, and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product is distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technology. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 2020, and IDC predicts that IoT revenue will reach around 357 billion in 2019, resulting in a lot of job opportunities in the IT industry. Want to become a part of the IoT revolution? Come and master IoT with EduRacer.
I hope so. Yeah, you're now got a basic idea about the Internet of Things. So, what the thing over here is,
The Internet of
uh, what is the thing over here is, we cannot directly go into an IoT learning platform. We require many things. So, what are the basic courses in ECE that will make us to uh, profound or very intelligent in certain areas? Now, listen here. When you take an electronics, you will be learning about electron devices. Yesterday, what we talk about PN diode, transistors, and all these things. Then, how to analyze these devices, how to bug these devices, we will be learning in the electronic circuits. Debug the devices, we'll be learning about the in the electronic circuits. You will be learning different analysis. Then this we call it to be an analog electronics, then the digital electronics. When these devices are ready, when you are ready with all this subject, then you directly learn about the LIC. Then if you know an LIC, you can go for a VLSI, and VLSI and microprocessor can go parallel, and with all this microprocessor knowledge, you will be learning the computer architecture. Here, one beautiful thing I'll tell you at the end. In communication, if you consider the first, you will be learning about the signals and systems, then whatever we have learned about the communication theory and digital signal processing, electromagnetic field, antenna, and digital antenna. I've repeated 2 times, sorry. And another one is a digital communication. So all these things are very important, and these things cannot work without the aid of electronics. And without the electronics, there is no communication. Without the communication, there is no electronics. When these two things are joined together, only you are getting an IoT. Can you tell? I'm asking one question. Without this microprocessor, whether a computer could be designed? No way. You cannot design a computer. Without this electronic devices or without this digital electronics, can you design a microprocessor? No, you cannot do it. So you know how this electronics plays a very important role in day-to-day life. Without this basic communication, Can you do networking, computer networking? No, right? The first ISO layer itself is a physical layer. You have to learn about the electronics. Without that, if you are learning about the network engineering, it's a little quite difficult, right? You can do it. Everyone can do straight away with the in-depth of the subject, but it's not that much advisable. As an engineer, it is not advisable, okay? An engineer, yesterday itself, I told that he should have a creative thinking, imagination, and that should be implemented, and that implementation should be for the useful for the society. All right. So if you want to be useful for the society, please learn from the basic, from the fundamentals. All right. And another thing which I want to insist on is advanced courses in ECE, ad hoc sensors, satellite communication, optical communication, wireless networks, digital image processing, and Internet of Things. Many more are there, but I'm just listing out this. In this area, you can do research. I mean, you can go for the higher studies. And this will be very useful for you. So always, I'm not talking since I'm an ECE staff, really practically nowadays this branch is more important. And one thing I want to say is, in ECE branch you will be also learning about C. What all the computer subject you will be learning is C, C++. You can easily learn. You'll be learning, and Python will be one of the course, and computer networks also will be one of the course. Computer architecture also will be one of the course. So you'll be learning both the software and the hardware. So you will be, when you're joining in the EC department, it is what to say, a double beneficiary or double dhamaka, we can say that like that. Okay, fine. Next, roles of EC engineers in this world: they can be service engineer, electronics engineer, software analyst, or they can be electronic design engineer. These are the designation given: desktop support consultant, network planning engineer, research and development software engineer, and hardware engineer, whoever might be. So these are all the designation. In this position and all, you can be placed. And I'll say you another thing also, right? Job opportunities in government sectors, if you take it, DSNL, ISRO, DRDO, Bell, BARC, INA, all this government sectors, if you learn, if you write once after your third year, when you're going in the fourth year, if you write your GATE exam, usually you can try out with this government job. And if it's going to be a private sector, Havels India, Bajaj Electronics, Score, Honeywell, 3M India, Philips Electronics, Bosch, Surya Roshni, everything, Bosch India and Surya Roshni, everything will be having your electronic. And also, if you consider a well-known thing is a Wipro and L&T also are concentrating on this electronic devices. If you consider, these are all the major sectors where there are job opportunities. You have n number of job opportunities. And next, before winding up, one thing I want to say is, right, the truth I'm saying is, more than a software engineer, initially a hardware engineer will be getting less paid, but at a boom, you can refer anyone, right? What is the pay will be given for an architect in an Intel, or in a device engineers in the Wipro or an L&T? What payment they are getting it? It is incomparable. They'll be getting more. Okay. So in this 2 series, thank you for the patience with me. I've taken extra some 2 or 3 minutes for you. And really, thanks for the opportunity given by the EC department of SA Engineering College, and also the chairman, the principal, and secretary and correspondent, everyone, and those who have participated and really interested towards listening. If there are any flaws, just pardon me. Okay. And I did some justice according to my knowledge. And thank you. And before winding up, I want to say a quote: walk like a king or a queen before being crowned as a king or queen. So before being an engineer, try to gain a knowledge. Walk means try to gain a knowledge like a king or a queen. Then only when you're walking on along the red carpet, you will be feeling as a king or a queen, or else you will be in a guilt that I have not learned anything, but I'm walking like a king or a queen. Don't feel that guilt in your life. Learn something and proceed. All the best for your life. Thank you. Thank you, everyone. Kavi Priya, can you contact someone? Yeah, Kahoot Quiz. That I'm not the in charge of the Kahoot Quiz, actually. Ishrat, please.
Yeah. Hello, guys. I'm Vaishnavi, and I'll be conducting the Kahoot quiz. Let me share the screen. I guess my voice is audible. Okay. So kindly, I request all the participants to note down the gaming pin. Go to kahoot.in.com and you'll have to enter the gaming pin that is 9036085, and you'll get into the Kahoot quiz one by one. Please enter your nickname as well. So I'm waiting for the players to join. Once again, I'm repeating. Kindly join Kahoot Quiz by entering the URL kahoot.it and further enter the gaming pin which is given on the screen, that is 9036085. Let us wait for a few more minutes so that people will join. Just one more to go, and okay. So let us start the quiz. So, welcome to the Kahoot quiz, and this is going to be like a recap for the session. Three, two, one, and the first question is: who is the first engineer being recorded? Your options are Einstein, Maxwell, Faraday, Imhotep. So please give your answers fast. Time is running out. You have 7 seconds with you. 5, 4, 3, 2, 1, and go. Wow, two of them answered the correct answer. So Pooja is on the top with the score of 805. Moving on, let us have the second question on the screen. The word engineer is derived from Latin, Spanish, Greek, or Arab. Please give your answers fast. The timer is running out. We have 8 seconds with us. Ooh, wow. 4 of them answered right, and the right answer is Latin. And Buffy is on the top with the score of 1181. Moving on. And the third question is, which one of the following is the purest form of semiconductor? Your options are silicon, germanium, both silicon and germanium, none of the above. Time up, and 8 of them answered right. That is right, both silicon and germanium. So Nitin is at the top with a score of 1876. Moving on. Electromagnetic theory of light is formulated by Colombo, Faraday, Tesla, Maxwell. 5, 4, 3, 2, and 1. That's right. The answer is Maxwell. 2 of them answered it right. Let's see who are they. Okay, so Queen and Vinod are on the board now, scoreboard. Yay to them. V equal to IR is Ampere's law, Maxwell's law, Lenz's law, Ohm's law. So this must be pretty easy for you guys since you'll be learning this from your 10th standard. That's right, it's Ohm's law. So let's see who is on the top. Queen is on the top with a score of 2, 6, 6, and 8. And followed by Buffy, Vinod, and Ganesh. Moving on with our sixth question. The first microprocessor is 4004, 8085, 4007, none of the above. Your timer is running out. Give the options first. 3, 2, 1, and the answer is right. That's right. 4004. And still Queen stops the scoreboard. Moving on. Ampere is. And the options are passive component, active component, both active and passive component, none of the above. The timer is running out. That's great. The answer is active component. So let's see who is on the top. Wow, Nitin has come into the board once again with the score of 2772. Moving on with the 7th, 8th question. The first bipolar transistor invented at Intel, Microsoft, Bell's Laboratory, none of the above. Any options? That's right, Bell's Laboratory. So let's see who is on the top. Poofy has come up with the score of 3,155, and Queen is still at the top with the score of 4,281. Moving on with our second last question. VLSI stands for Very Large System Integrated, Very Long Scale Induction, Very Large Scale Integration, none of the above. And the timer is running out. 3, Yes, the answer is very large scale integration. Moving on, the Queen is still at the top with a score of 5165. That's a great one. The last question, wireless communication is done through, and your options are antenna, copper wire, cable, both A and B. This must be a very easy question for you guys. The timer is running out. And the answer is antenna. That's right. So let us see who is on the podium. Number 3 is Ganesh. Number 3 goes to Ganesh. And number 2 goes to Goofy. And number 1 goes to Queen. Wow, she topped it. The name has, as it is, she has topped it. She is a queen, I guess. And thanks for all the runner-ups and thanks for all the participants. Thank you.
Thank you, ma'am. Be thankful for everything that happens in your life. It's all an experience. Thank you, sir, for your outstanding discussion. We have now reached the end of this session, and this is the time to extend our gratitude for the successful completion of today's event, Evolution and Advances in Electronics and Communication Technology, Part 2. No duty is more urgent than that of returning thanks. I deem it my privilege in proposing the vote of thanks. At the outset, I would like to extend my sincere gratitude to the management for providing an opportunity and extending full support to organize such an event. I would like to thank our principal, sir, Dr. S. Ramachandran, for being a source of motivation and guiding us to conduct such events. I would like to thank our most eminent speaker, Dr. Benjamin Joseph, for spending his time with us and enlightening the day with his knowledge. Profound thanks to the event organizing committee for playing a pivotal role in organizing and ensuring the smooth conduction of this event. I also thank all participants for accepting our invitation and extending the full support. Dear participants, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificate. I repeat, dear participants, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificate. I would like to complete this day with the final quote: live a life full of humility, gratitude, intellectual curiosity, and never stop learning. So, once again, I repeat, the feedback form will be posted in the chat box. Kindly do fill it and get your participation certificate.